Hey everyone, in this video we'll be going over exponent rules. The first rule that we're going to cover is the product rule. And as you can see, if you have x to the m power times x to the n power, that's going to equal x to the m plus n. So essentially, when your bases are the same, base being the number getting raised to the exponent, when those are the same, you add your exponents together. So when your bases are the same, you add the exponent. So let's do a couple. We have x to the third times x to the fifth. My base of x is the same in both, so that's just going to become x to the eighth. Why does that become x to the eighth? Well, if you rewrite x to the third, that's x times x times x. X to the fifth, which I'm multiplying x to the third by, is x times x times x times x times x. So there's 1, 2, 3, 4, 5, 6, 7, 8 x's being multiplied together, meaning x to the eighth. On the next example, you have 6x to the fourth y to the sixth times 2x to the eighth y to the seventh. So the parentheses in this case only means multiplication. You're multiplying this quantity times this quantity. So I can write that statement without the parentheses. And you got to remember that multiplication is commutative, so I can move things around, meaning I can multiply the 6 and 2 together, because that could be written as 6 times 2, x to the fourth, y to the sixth, x to the eighth, y to the seventh, meaning the same thing. So 6 times 2 is going to become 12. Now look at bases that are the same. The x's are the same. So you have 4 here and 8 here, so that would be x to the 12th. And then your y's are the same. So the y's are the same there, the bases are the same, so y and 6 plus 7 is going to be 13. So multiplying those all together, you get 12x to the 12th, y to the 13th. Now, you can rearrange these. This can say that's the same thing. I can switch the x and y. I can write this a variety of ways, but normally you put the number in front and then alphabetical order. X comes before y. The next rule we're going to look at is the quotient rule. So x to the m over x to the n equals x to the m minus n. And I teach this a little bit different way. If you have h to the fifth over h to the third, according to the rule, you subtract the top minus the bottom. So this is going to be h to the 5 minus 3, which would be h to the second. Now, how I like to teach this is the first time I do it, I will write these out. H to the fifth is h times h times h 5 times. And then h to the third is 3 of those. Sorry about that. And when I have a fraction and I have the same letter on the top and the bottom, I can go ahead and cross those out. So what that leaves me with is h to the second on the top, because I have 2 on the top. I can put that over 1, but the 1's not necessary. So in this example, you can take, you see the x's are the same. So I can do x to the first minus 4 and y to the fifth minus 2. That's going to become x to the negative 3, y to the third. So that is an equivalent statement. Most of the time you do have to get rid of negatives, and we'll go over that in a minute. But what happens here, and the other way I teach it, let me change my color. Let's do that in green. If I do x and then 5 y's and then 4 x's and 2 y's, you can see that a y will cross out, a y will cross out, and an x will cross out. So I have 3 y's left on the top, so y to the third, and 3 left on the bottom. So this red and this green are equivalent statements. maybe you can see what we're going to do with those negative exponents. But I'll show you that in just a second. So the same thing. And once you get the hang of this, you can kind of see, well, if I have one x on the top and 4 on the bottom, there's 3 more on the bottom. So x to the third is going to be kept on the bottom. If I have 5 y's on the top and 2 y's on the bottom, then that would leave me with 3 total on top, leaving me with y to the third. So let's look at this one. You have numbers here this time. 5d to the third r over 2d to the 7th times r to the 6th. So since the 5 and 2 are just like our numbers, 5 over 2 doesn't reduce. There's no number that goes into both of those. Now look at your d's. There's 3 d's on top and 7 d's on the bottom. So that means that there's 4 d's left on the bottom. In r's, I have 1 r on top and 6 on the bottom. So that means if I wrote those out the long way and then crossed them out, I could only cross 1 out. So I'd have r to the 5th left on the bottom. So those are the quotient rules. Now the power rule, you have a x to the m raised to the n power. And you can see if you have an exponent raised to an exponent, you multiply your exponents. So for this example, x to the 5th to the 3rd is going to become x to the 15th. You just multiply. And you multiply because if I have x to the 5th to the 3rd, that means that quantity happens twice. And that reverts back to our first rule. By the same base, you add the exponents. So 5 plus 5 plus 5 would be 15 as well. But you should know that multiplication is just repeated addition. So when I add these, it's the same thing as multiplying 5 times 3. With my k, that would be k to the negative 14th because it's a power to a power, so you multiply the exponents. Okay, and here's the next rule. If you have x, y in parentheses and raised to the m, so you have 2 or 3 different things and it's raised to the exponent, everything in there gets the exponent. So for example, if I have ht to the 5th, the exponent on the h is a 1 and the exponent on the t is a 1. So 1 times 5, because it's a power to a power, just like the last slide, is h to the 5th. And then we have t to the 5th, because 1 times 5 would be 5 as well. Here, you have d to the negative 3 times h to the 6 raised to the 5th. So everything gets the 5. So we have d to the negative 15, h to the 30th. Once again, I'm going to show you in a second how you get rid of negative exponents, and we'll come back to that problem. And then the last problem, we have a lot going on here. Just take it one piece at a time, so I'm going to handle this first. X to the third raised to the negative 5, x to the third times y to the negative 4, all raised to the negative 5. So everything gets the exponent. X to the negative 15th is what that would become, and then y to the 20th. 3 times negative 5 is negative 15, and negative times negative is a positive. Now here, this is where some students get confused. This is a number here, but it does have an exponent of 1. So this becomes 3 to the third. Even the number gets the exponent. X to the negative 6, because negative 2 times 3 is negative 6, and then y to the third. Now we can put things together. So 3 to the third, you can either leave that as 3 to the third, or most of us would probably put 27 there, because 3 times 3 times 3 is 27. My x's are my x's are here, same bases. So add those. Negative 15 plus negative 6 would be x to the negative 21. See, I'm adding negative 15 and negative 6. Putting those together gives me negative 21. And y, I'll do that in blue, same base, add 20 plus 3 to get y to the 23rd. Okay. And our negative exponents. You have 1 over x to the negative m, so you have a negative exponent on the bottom. What happens is you make that positive by moving it up to the numerator, and always remember you can put anything over 1, so I'll move that up to the numerator. If it's in the numerator to begin with, I can move it down to the denominator. So the shortcut is cross the line, the fraction line, it changed the sign of the exponent. So b to the negative 8, since that's not in a fraction, go ahead and put it in 1. And then draw your line. Cross the line, change the sign. So since this is a negative exponent, I need to move that down. Now I don't have anything left on top, but I have to put a placeholder of 1. That 1 holds the fraction there. Alright, so let's look at this one. If it has a negative exponent, you can move it. So negative 6 is a negative number, but it doesn't have a negative exponent. So it's going to stay up top. M to the negative 5th is a negative exponent on the bottom. So cross the line, change the sign. That's going to move to the top. Now this could be over 1, but anything over 1 is just itself. So that 1 is not necessary if everything's on top. But if everything moves to the bottom, the 1 is necessary, like in this example. Okay. B times c to the negative 5th over b to the 4th c to the 8th. So negative exponents, you move them. So b stays. It's got a positive exponent. C to the negative 5th, that's going to move to the bottom and become positive. B to the 4th is going to stay where it is. And c to the 8th will stay. All of those are positive, so they didn't move. Now reduce again if you can. Notice I have a b on top and b's on the bottom. So I have 1 on top and 4 on the bottom, so that would leave me with 3 on the bottom. Now c to the 5th times c to the 8th on the bottom is going to become c to the 13th. Because you add the exponents. And that's just going to be a 1 on top for the placeholder. Okay, the next problem, there's a couple of ways to do this. You can clean up each fraction, so let's clean up this fraction. Right here, I'm going to get rid of negative exponents. X to the 4th is going to stay, and so will y because they don't have negative exponents. X to the negative 10th would become x to the 10th on the top. Notice I don't have anything left on the bottom, but that's okay. I can just put 1. X to the 3rd is going to stay, and y will stay, and y to the negative 5th will move to the top and become positive. Now notice everything is on top now. So when you're multiplying fractions, you put the tops together and then the bottoms. You multiply the tops and the bottoms. So let's change this to green. We have x, x, and x. So we have the same base. So go ahead and add those. 4 plus 10 plus 3 is 17. And y, here, here, and here. I have 1, 1, and 5, so that's 7. And once again, if everything's left on top, I do not have to write it over 1. Okay. Alright, and the next rule, anything raised to the 0 is 1, so x to the 0 is 1. So looking at this problem, you have a quantity. All of that's raised to the 0 power. So that's really just 1. Notice in the next example, you have all this mess that looks pretty complicated on the inside here, but everything in there is getting raised to the 0 power. So all of that becomes 1. And I hope that helped with the properties of exponents.